Hello everyone, I am Sanskar Shukla and I'm going to explain you about the MD5 algorithm in a whole. As my friend Vivek Kumar has already told you about hashing, I'll continue this series of using John the Ripper tool to achieve hashing in Linux, but as you know, it's not an easy deal. So we divided the whole thing into three crucial parts. Vivek has already told you about hashing. Now me, I'm going to tell you about the MD5 algorithm. To start with that, I've made a slide. I'll explain everything in detail, so just be patient and hear me. First of all, before starting, I must remind you of what hashing is or what the hash functions are. These are extremely useful and appear in almost all forms of information security applications. A hash function is a mathematical function that converts a numerical input value to another compressed numerical value. The input to the hash function of arbitrary length, but output is always a fixed length. Values written by a hash function are called message digest or simply hash values. You already know about the features of hash functions like fixed length output, that is the hash value. That is, hash function converts arbitrary arbitrary length data into a fixed length, that is hashing the data. Compression functions, digest, n-bit hash functions. I'm just reminding you. Now we'll start over the MD5 algorithm. Firstly, we'll understand about the MD5 algorithm. Then we'll implement it on the Java compiler itself. So let me just begin with the presentation. Before that, all you must know that MD5 is a message digest algorithm, which is the fifth version of message digest algorithm developed by Ron Rivest to produce 128-bit message digest. MD5 is quite fast than other versions, of course, which takes the plain text of 512-bit blocks, which is further divided into 16 blocks, each of 32-bit, and produces the 128-bit message digest, which is a set of approximately 4 blocks, each of 32 bits. It produces the message digest through 5 steps: padding, append length, divide, input into 512-bit blocks, initializing, chaining, up process blocks, and 4 rounds. Uses different constant in each iteration. Now, we'll know about what is the use of a MD5 algorithm. It was developed with the main motive of security, as it takes an input of any size and produces an output of pardon, a 28-bit hash value, 128-bit hash value, sorry. To be considered cryptographically secure, MD5 should meet two requirements. It is impossible to generate two inputs that cannot produce the same hash function. And the second, it is impossible to generate a message having the same hash value. Now, let's get on with the PPT. This slide, I'm going to just introduce the outline about how introduction, MD5 algorithm structure, implementation steps, performance, a comparison between MD4 and MD5, and last but not the least, summary. So as I told you that Ron Rivest in 1991 developed MD5 algorithm. According to RFC, message digest algorithm takes as input a message of arbitrary length and produces as output a 128-bit fingerprint or message digest of the input. Now, we can all say in layman terms that it is the compressed thing. Now, in this, I've just shown you the figure about how padded message is converted to digest. These padded messages are converted to digest, and this 128-bit constraint adds to it. And finally, we get the message digest. Next slide, please. Now, coming to the implementation steps, that is, appending padding of bits. Padding means adding extra bits to the original message. So in MD5 original message is padded such that its length in bits is congruent to 448 modulo 512. Padding is done such that the total bits are 64, less being a multiple of 512 bits length. Padding is done even in the length of the original message is already congruent to 448 modulo 512. In padding bits, the only first bit is 1 and the rest are 0. Coming to the second step, that is appending the length. After padding, 64 bits are inserted at the end, which is used to record the length of the original input, modulo 2 to the power 64 to be precise. At this point, the resulting message has a length multiple of 512 bits. Now, the third step, initializing the MD buffer. A four-word buffer A, B, C, D, as you can see on the screen, is used to compute the message digest. Each A, B, C, D is a 32-bit register. These registers are initialized to the following values in hexadecimal. Now comes the step 4, that is the implementation. Step 4, that is processing message in 16-word block. It uses auxiliary functions which take the input as 332-bit number and produces a 32-bit word output. These functions use logical operators like OR, XOR, and NOR. The content of four buffers are mixed with the inputs using this auxiliary buffer, and 16 rounds are performed using 16 basic operations. This is something that I told you earlier about how the operations are being held. This is the performance. Now comparing the MD5 with MD4. Now MD5 has a fourth round. Instead, MD5 has a fourth round instead of MD4, which only had three rounds. Each step has a unique additive constant. The function g in round 2 was changed from, as you can see on the screen, from yz in the last term to the naught of z, and also the second term. Each step adds in the result of the previous step. The order in which input words are accessed in round 2 and round 3 are changed. The shift amounts in each round have been optimized. The shifts in different rounds are distinct. Now, we all have seen that how fast a 32-bit machine performs. Comparing to the digest algorithms, MD5 is simplest to implement and provides fingerprint or message digest of a number of arbitrary length. MD5 is considered to be one of the most efficient algorithms currently available. Thank you, and let us see the implementation part.